All right, for the Go section of the Unit 3, Lesson 4 practice, we've been working with domain and range, so hopefully this won't be too hard for us. For each graph, we're going to identify the domain, the range, and whether or not the function is increasing or decreasing. So remember, your domain is going to be all of the x values where your function exists. Your range is similar, but for your y values. So the range of values where your y values take place, I suppose. And lastly, whether or not the function is increasing or decreasing. So in number 14, if I look at my x-axis, this function exists at -5 because I have a closed circle at -5. However, when I get to where x equals 2, this function does not exist here. So that means that my domain gets really close to -2, or to +2 rather, but never goes through 2. So if you look at the way I just wrote that we said we go through -5, and then the function exists for all these x values, and then it gets really close to 2 but doesn't go through it. That gives us a clue how to write this with interval notation. So with interval notation, I could say from and including -5 up to but not including 2. So remember, the brackets include a value, the parentheses exclude a value. Now, if you really want to write that with a compound inequality, you could write it like that as well. I think interval notation is easier. All right, so for the range, same idea. I want to go from my min to my max, but remember, when x equals 2, this function doesn't exist here. So this function never actually becomes -6 because that is what we call an open circle on the end of it. So it's not closed. So I won't actually have -6. I'll have to exclude it from my range, but my function does equal 5. So when x is -5, my greatest y value or my maximum is 5. Okay, so this function, for the range, I would say from but not including -6 to and including 5. So that's how we would do that with interval notation. We always want to make sure our lesser value comes first. Alternately, I could show that y is always less than or equal to 5, but greater than -6 with a compound inequality. All right, lastly, the function is strictly decreasing. When I say strictly there, that is a very mathy way of saying the function is always decreasing. So it is never increasing, it's just always decreasing. All right, we'll go through the rest of these kind of faster because they are kind of the same thing, right? The domain, the arrow on the function in 15 indicates that that graph goes on forever and ever and ever. So my domain really starts at -infinity. And remember, infinity is not a number. It's just a concept. It means keep getting more negative. Like, think of the most negative number you could think of and subtract 1 and you have a more negative number. When I get on my x-axis up at where x is equal to 4, I could see that my function does not exist at 4 because of that open circle. So my domain also does not include the 4. So I could write this as from -infinity to 4 using parentheses. I could also just say values of x that are less than 4. Those mean the same thing. All right, the range, again, the lowest value we get close to is -6, but the function does not exist there. So -6 is not part of my range. And for this function, well, it kind of appears that we have an asymptote here at -1. So I'm thinking that this looks like a part of an exponential curve where we might be reaching this asymptote. If that's the case, we shouldn't include -1 in our range. But to be honest, we might need more information to know that for sure. I'm going to go with the range is from -6 to -1. I'll be honest with you, it's not super clear from this graph without knowing more information. You could also write this as like x is less than -1, or sorry, not x, y. Remember, range is y values. Less than -1, greater than -6. All right, so again, is the function increasing or decreasing? Well, from left to right, the y values are getting lesser and lesser, so the function is strictly decreasing. And if you don't include the word strictly in your answer, that's okay. That's just something we say to indicate that it's always decreasing. All right, number 16, the domain's a little bit easier. It's hard to tell, but there is a little arrow here, an arrow here. So my domain is all real numbers because the arrows indicate that this graph continues forever to the left and the right. So you could use that symbol to show all reals. In interval notation, we would show that this domain is from -infinity to +infinity. So either or. Or you could also just say all real numbers. So there's a few different ways that we could express the domain in number 16. The range, I'm going to say again, it really kind of looks like it might be a reflection of like a type of exponential function. So I'm not going to include 4 in my range because what I believe I'm seeing is a horizontal asymptote here at 4. Now, I have a lot more experience picking out asymptotes than you do at this point in Algebra 1. So if you're feeling unclear about this, I do understand. Like, I get that. So for our range, the least y value, well, this function is going to continue down forever and ever and ever. So we would start at -infinity, and then we would go up to +4, but I don't believe that this range includes 4. Right over that in greens for consistency. We could also say y values less than 4. All right, so this function is increasing. In fact, we could say it is strictly increasing. So from left to right, it's always going up, although it does look like we have an asymptote. The function still increases there. It's just so like such a small increase that it still never reaches 4. All right, 17 I think is a little bit easier. I think those last two curves have been kind of hard to interpret. So in 17, actually I think this is way easier. My domain, well, my graph starts where x is 1 and my graph stops where x is 6. And I have closed circles on both ends of this, what looks like a line segment. So that means I include both those x values in my domain. The function exists when x is 1. It exists between x equals 1 and x equals 6. And so my domain are all the x values from 1 to 6. I want to include them. Alternately, I could say x is, or 1 is less than or equal to x, which is less than or equal to 6. That is how we could write that using an inequality. All right, for the range, pretty small range for this little function. If I look at my y values, the function at 1 exists at 1 and has the function value of -2. And then when x is 6, my function value is -1. So I want to include both those numbers in my range, or I could show that like y is less than or equal to -1, but greater than or equal to -2 if you prefer to write a compound inequality. I believe personally that interval notation is easier. The function is strictly, meaning always, increasing. Well, meaning always across its domain. All right, number 18. Oh, domain and range, easy peasy, all real numbers. The arrows indicate that the function continues to the left and right, also up and down. You could also show negative to positive infinity if you are writing interval notation. Or you could say in words all real numbers. This linear function is strictly increasing. All right, 19. Our domain begins at -5. I've got a nice closed circle there, and it continues indefinitely. So I could say my domain is from -5, including -5, to positive infinity. And again, we just always use parentheses because infinity is not a value, it's an idea. The range, we're gonna maybe just take a guess a little bit on this range. I think that lowest value looks like it's 1/2. I don't know. I don't think we have enough information here to know for sure. So I'm going to estimate that y value as being at 1/2 or 0.5. And then I can tell that as this function continues to the right, my range keeps going up, up, up. My y values go up, up, up forever. So my range, I'm going to say, is from 1/2 to infinity. Or again, we could use interval notation with all of the, inequality notation with all of these. For my domain, I could have said that x is greater than or equal to -5. And for my range, I could say that y is greater than or equal to 1/2, but we are just kind of taking a guess that that y value is 1/2. The function's always increasing. So from left to right, those y values are becoming greater. So we could say this function is strictly increasing. I would accept increasing without the strictly. All right, domain on this one, 5 is the endpoint of my domain. The arrow indicates that we keep on going forever and ever. So my domain is from -infinity to and including 5, or I could say that x is less than or equal to 5. My range on my y-axis, well, the function goes down forever, but it stops at 1 when x is 5, so my range is from -infinity to 1. Or I could say y is less than or equal, not 1, sorry, -1. Y is less than or equal to -1. Might help if I label my axes there. All right, this function is increasing. Don't let the arrow fool you. We always read the graph from left to right. From left to right, the graph is going up. So the function is strictly increasing. All right, lastly, number 21, our domain is all real numbers. Our range is only positive numbers. You could say that in words, or we could just say from 0 to infinity, or we could say y is greater than 0, but this is undoubtedly an exponential curve here. And then lastly, is this function increasing or decreasing? The function is strictly decreasing, because from left to right, the y values are decreasing. All right, that is it for the Go section.